All right, I am going to start the presentation of the third LBRN-LONI Scientific Computing Bootcamp. Before we start the actual programming tutorial regarding Introduction to Python, I am going to give a very short opening remarks about scientific computing. So this is going to take only 10 or 15 minutes regarding a very, very short overview of the scientific computing. We will also talk briefly about agenda for the bootcamp, about what we're going to do. And also we talk a few words regarding the computing platform we are using for rest of the week that we are going to use for the bootcamp. Bootcamp will be recorded. So if you happen to miss any part, if you have some other kind of errand you need to run, feel free, but make sure you follow the whole presentation for you to be able to start your hands-on exercises. Because the hands-on exercise is the best way that you can actually tell yourself whether you have actually understand the course material. Although the recordings are online, we strongly recommend you to follow the live session as much as possible. Because in a lot of cases, you know that we will have a recorded training case, and you know that the recording is online, and actually you never take a look at it. So we will still strongly recommend you to follow the live session if you can. All right, we see enough participants joining right now. So I'm going to still repeat our outline for the very short opening remarks. We will have a very brief overview of the scientific computing. We will talk briefly about the agenda for the bootcamp, and we'll also talk about the computing platform. We will be using the Google Colab as the cloud computing platform. All right, so we have like about 3 or 4 slides regarding about what is scientific computing. This is actually a very, very large topic, and you can spend even 4 or 5 years for getting a PhD on scientific computing or computational science. And we try to summarize all the topics in one slide. What actually we're going to talk about in the slides. The slides is that we want to emphasize the scientific computing is a collection of tools, techniques, and theories combined together to solve a mathematical model of a problem in science and engineering. And we refer this Golub and Ortega in 1992 publication. Actually, what summarizes the best for scientific computing is the left picture. The left picture shows in order to do a scientific computing, you need a combination knowledge of computer science. You need a mathematical background of the numerical methods. And you also need your own knowledge of domain problem specific modeling. The 3 areas combined together can help you or make you be able to start with a scientific computing. It is actually a very rapid growing multidisciplinary field. Uses advanced computing capabilities to understand and solve complex problems. All right, when we say it needs the knowledge of numerical methods, it needs to requires a background knowledge of computer science. It doesn't mean you have to use a computer to perform scientific computing. Earlier in the 16th century, people has already invented some kind of platform of doing scientific computing on abacus or on a calculating table. So although The scientific computing requires a combination of tools, technique, and theories. Requires you to do that, but it doesn't actually require you to have to use a computer to do that. As long as you have a tool, you have a platform, and then you can do scientific computing. But nowadays, the computer becomes so much powerful. It's very, very powerful. So almost everybody uses a computer, different type of computing platform to perform scientific computing. All right. So why we need to do scientific computing? I think the answer is quite clear. It's nowadays the third pillar of science. In addition to theoretical analysis and experimental study, it becomes another pillar of science that cannot be replaced, especially in case of some other means are impossible to do. For example, if you look at the left picture, it shows you, I think almost everybody should see this picture. The picture shows the picture of a black hole. And without scientific computing or processing those data from what I heard is about 50 terabytes of data, you are not able to actually get this image. And second situation is that perform other type of research is very, very costly in both time, money, and human labor. For example, if you do an aircraft design, nowadays lots of those design activities, those design analysis are completely done on the computer using a CFD analysis. Otherwise, if you try to do this aircraft design using a wind tunnel, in some cases you will still need to do that, but the cost of doing a wind tunnel analysis is very, very costly. In third case, for some kind of simulation that's either dangerous or undesirable to do that. For example, I think currently the UN has banned the nuclear weapon tests. So if you want to actually do some kind of research for this type of analysis and the numerical analysis, scientific computing is the only way that you can do this type of simulation. So from all these, the three impossible means, so that why we need to do scientific computing, it's actually a very, very important, irreplaceable, indispensable way of doing research for everybody's research or study work. I saw on the registration, lots of people come from different area. You come from physics, you come from chemistry, you come from biology, you come from different areas of engineering. And needless to say why scientific computing is so important in your daily research activities. All right, so next slide is we talked about what is scientific computing, why we need to do that, and third one is how to do that. As we said in the previous slides, you need your own theoretical background in your own research area for the specific problem. So that you need scientific theory and algorithm from your own study or research background. And that is actually not we're going to focus today. We will be focusing on using software or hardware to help you to perform scientific computing. For the software and hardware, they are the platform that you need to carry your scientific computing on. Let's first talk about the software. I would categorize the software into both the general purpose software and dedicated software. The general purpose software, as you might see here, I list Microsoft Excel. It's actually a wonderful tool to do scientific computing. And lots of engineering designs are actually done on using the Excel. So don't be shy if you're using Excel to do scientific computing. It's a wonderful thing to do, and actually a lot of buildings and maybe the a lot of buildings, levees, a lot of structures. I was a civil engineer before, so actually I worked in a design company. I know lots of structures, lots of buildings, bridges are actually done using the Excel. Excel is a wonderful tool to do scientific computing. Also, MATLAB is a general purpose software to do scientific computing. Many of you might already use that. And also, what we're going to focus is the Python and R are the two most popular programming language for doing scientific computing, especially for the data science area of usage that has been very popular, especially for the past few years. So we're going to focusing on Python and R. So those are the cases of the general purpose scientific computing software. Also, we have dedicated software such as ANSYS, which is the engineering tools for doing different type of simulation, like the CFD simulation, structural analysis, solid mechanics, even the electronics, they are done, these type of analysis are done by using the ANSYS software. It's a specialized dedicated software. Also, many of you coming from chemistry or physics, you probably have already heard of these dedicated molecular dynamic software such as LAMP, SCROMAX, or AMBER. But actually, the scientific computing is a combination of lots of techniques, and in many cases, we need both software. We need both the general purpose software and also the dedicated software to perform the goal, to achieve the goal of our research, either the academic research or special type of engineering analysis. So these are we talk about the software. Also regarding, you need to run software on different type of hardware platform, right? So for the hardware wise, definitely you can do it on your laptop, on your desktop, or you think someone thinks the desktop or laptop is not powerful enough. And you need, and your advisor might buy you a lab server. These are type of like standalone consoles for you to do simulation. But what we are going to discuss, or we're going to use in today's or this week's bootcamp, is use the cloud computing platform, which provides you a uniform interface, and it requires you install actually nothing on your own computer, and how we are going to do the scientific computing, programming R and programming Python through a cloud. And this is actually a wonderful platform, and it requires you to do the minimum configuration and can let you focus more on learning the language itself and learning using focusing more on the either your language itself or either focusing on the research problem itself. The third type of hardware platform is the supercomputers. And the problems we talk about in this week's bootcamp is either like toy problems, example problems. They can be completed on a relatively small cloud computing platform. But if you do need a large type of analysis and you need to run these on the supercomputers, and we manage one of the LSU and the statewide HPC clusters. And if you see on the bottom right corner, we show you dedicated on-premise the LONI 2 Queen Bee 2 cluster. The Queen Bee 3 cluster is also will be open in this month. So these are the third type of hardware that you can really perform your large scale numerical simulation type of scientific computing platform on. Those are the third type of hardware. So in this bootcamp, we'll be focusing on the cloud computing using the Google Colab. And we are going to detail that in throughout the week regarding its usage. So purpose of this bootcamp, if you have already take a look at the course agenda page, which I have showed you during the when you register for the bootcamp, you should see that we have the focus of this bootcamp. We're going to talk about Python, we're going to talk about R, and we're going to talk about deep learning. So we hope you by Friday, you should at least have a basic understanding for the usage of the very popular scientific computing programming tool. One is Python and one is R. And in order for you to get a real application to practice the scientific computing programming tools, we get you a deep learning as a practice of using the Python and R programming language. All right. So this is the purpose of this bootcamp. We will learn Python on Monday and Tuesday. We will learn R on Thursday, on Wednesday and Thursday, and also we will going to learn the deep learning on Friday. Okay, someone is talking about let me turn the okay. Q. All right, course agenda. Many of you already see that. Today we're going to talk about introduction with the overview I'm doing right now for introduction and Python basics. Day 2, we are going to talk about a little bit about using Python for some advanced features for scientific computing. And day 3, day 4, we're going to talk about introduction to R and intermediate R. And on day 5, we will be focusing on deep learning. Regarding the source repository, I have actually shared through the both. I sent you a reminder which contains the source code repository, and it is also found in the chat window on the very top of today's chat history. You should be able to find that. And the computing environment, we are going to use the Google Colab, and that's the link. Today's link you can also find in the source code repository. And regarding the organization of each day's hands-ons and lectures, we're going to talk about the morning sessions, which is basically lectures, tutorials. It's on the morning from 9 to 12. And mostly we don't think the tutorial will be 3 hours long. We'll have a few breaks. So feel free if you have anything, everything will be recorded. And when the recording is available, will be posted. So if you happen to miss anything, please just review the video. Also, afternoon sessions will be discussion-based question and answer for your hands-on exercise. So if you have troubles, anything using the computing platform, or you have any trouble understanding or figuring out the problems in the afternoon sessions for the exercises, please join the afternoon sessions from 1 to 4 p.m. We will be using the Zoom breakout rooms for you so that you are able to have a small group of people standing in the same Zoom break room, and we're going to discuss further regarding the minor details of those exercises. And as I said earlier, although the recordings will be available, we strongly recommend you to try to follow the live session. Some of you think, okay, there is a recording available, and I can look at it later, and even after a year, you didn't even have a chance to look at the recording. So please try your best to follow the live session and solve any problems you have already had during the exercises. All right, last, we're going to talk about the Google Colab. As I said before, the Google Colab is a cloud computing platform. It provides you a uniform interface for you to program either Python or R. It requires you zero configuration. It gives you free access to the GPUs. It allows you easy to allow you to do sharing your code with somebody else. For example, if you do some coding using the Google Colab notebook, and if you want to share your result with your advisor, you just share it with your advisor by simple a share. So especially under this pandemic situation, if you want to share your code with someone, it's just a simple click. It's very easy sharing. And most of all, using the Google Colab platform, it allows you to focusing on the learning the Python or R language itself, instead of working on the installation and configuration of computing platform, which can take you a half day to do that, depending on the different type of hardware you are using. Someone come with a Mac, someone come with a Windows, someone come with a laptop, someone come with a server on your lab. It's the uniform platform. And we would strongly also encourage you to write your code using the Google Colab in the future. It's free and it's very powerful. All right. I think the next time, the next two slides are regarding using the Google Colab notebook from the GitHub. So I'm going to just demonstrate how to open the Google Colab notebook, also demonstrate how to access our source code repository. So for any of you, if you have go to the our course repository, which is the LSU HPC Help LBRN-LONI Workshop 2020. If you can see day 1, you can actually see the slides, which I'm not going to open today. What I'm going to focus is going to open the introduction to python.ipydb. So navigate yourself to the LSU HPC Help LONI Workshop 2020, day 1. And you open the intro python.ipynb. It will take a couple of minutes to open the Colab to actually let the GitHub display the content of the Jupyter Notebook. And what you need to do is to find this open in Colab link, click it. It might take you a few minutes to do that. So now it opens the Google Colab interface. It's actually a Jupyter Notebook. We call it the Colab Notebook. For you to be able to see this introduction to Python Colab example. And we will be using this notebook to perform the actual Python and R programming. Remember, after you open this Colab notebook in the cloud from the GitHub, remember you need to do one more step, is to copy this to Drive. Otherwise, this notebook is read-only and you are not be able to make changes. What you need to do is to click the copy to Drive. And it will create a copy to your own Google Drive, and you will now then be able to make changes to the platform, to the Jupyter Notebook and actually program it. Otherwise, it will show you it's on a playground mode and you are not able to program it. All right, this is a very quick overview of the Google Colab platform. And I'm about to finish my part of the presentation. And there is a possible bug of GitHub. And if something went wrong, you can paste the Google Colab link to the nbviewer.jupyter.org. And I hope so far, because I don't see that this morning, but if you happen to see that when you click the, let me go back. Okay, so if you go to the GitHub repository, and if you happen to have a problem opening the Colabtory notebook, and it should render that and give the presentation of the opening Colab link. All right, so I know some of you might have questions. So if you have questions, there are two ways of asking the question. One way, or the preferred question, raise your hand and we can unmute you. All right, so it's about 9:30 now. Let's see if we have any questions. Okay. Okay, that's me to erase the whiteboard scribe. I'm going to do that. But if you have any questions, please either raise your hand or type your question in the chat window. Okay, someone is asking me if do you want us to do the MB viewer? If you open the Google Colab from the GitHub, doesn't work, and please use the nbviewer.jupyter.org. Unless it's absolutely necessary to do. If the first preferred way is see if you can open the Colab from the GitHub. If you can open Colab from GitHub, then it's perfectly fine. There is no need to use the MB viewer. Let me see if I can, there's a way to, okay. First time I see someone is using the screen sharing. All right, so if I don't see any other problems, okay, if you're having trouble, can you first type your window, type your problem in the chat window? It's okay, since Cassie will start the Python session 1 in a few minutes. So if you have trouble, you can still follow Cassie's window. Cassie will repeat the same procedure of opening the Cassie will repeat the procedure of opening the Jupyter notebook from the GitHub repository. So if you have any trouble, this is just like a pre-exercise. So feel free, if you have any trouble, don't following the procedure, you can follow Cassie from the following session for how to opening the Jupyter notebook from Google Colab and start working on it. And if you do have any trouble, and during the incur exercises, during the morning session, it's still fine. We prepared the afternoon session for you to be able to follow if any trouble and difficulties following the morning tutorial. It's still fine, and we will resolve those problems by looking at your screen by talking to you directly through the breakout room in the afternoon. We will still be able to resolve your problem because due to we are doing it on a pure online platform, so we are not going to work over your shoulder to actually type. Use your mouse on your computer, but we prepare the afternoon session for resolve any type of specific problems, and we can actually look at your computer screen. So don't worry if you have really have trouble following what we are doing right now for the hands-on. It's okay. It will be recorded. And what you can do is you can actually look at Cassie's window and try to follow. If you are not able to follow the exact steps, we will try to resolve in the afternoon through the breakout room sessions. We're going to share your screen on one-to-one, and we can also control your laptop. So feel free, don't worry too much if you have trouble unloading the laptop, the computer notebook or anything. It's perfectly fine. We have prepared for that in the afternoon session. So if you do have trouble, follow Cassie's screen and try to understand what's happening on her screen to be able to understanding the programming Python, focus on the language itself instead of focusing on the detailed exercises. And we'll try to resolve those problems in the afternoon breakout room sections. All right, thank you. And this is my part of the presentation for an overview. I am a little bit over time, so I now hand my chat to Cassie so that Cassie can start with her presentation. So give me a moment. I'm going to hand, so Cassie can. Okay, so Cassie, you can start your presentation. I'm going to mute myself.
Okay. Hello, everyone. I'm Kathy Traxler. I work at the Center for Computation and Technology, and Lo and Fung graciously allowed me to come and practice my Python tutorial with you all. I only get to do it 2 or 3 times a year, so I take every chance I can. Earlier, you all went to the LSU HPC help at GitHub. So this is where I'm starting from in case anybody joined us a little bit late. And from here, we go to day 1 and click on day 1. And then we're going to come back and click on Intro to Python, which will take us to that particular tutorial. Now we can't do any practice or typing in this tutorial, so we click Open in Colab. And you should see this. Here I've got a copy of Intro to Python Colab right here. And Google Colab is It's a really cool resource, whether you're doing parallel programming or serial programming. It helps you. It's a quick place to go and type in demo code to make sure you've got your algorithm correct and to easily debug what you've got. Today, we're going to talk about Python programming. So the first thing I want is there anyone that is not in Google Colab and ready to go? Okay, so if you save a copy in Drive, that's the way to do it. If you have a GitHub account, you save it to GitHub at the end, and I will do my best to remind you. You have to have a Google account. I can't imagine anybody not having one just because so many people use Google Docs and Google spreadsheets, but if you save a copy in Drive, it comes up and it should tell you creating copy. And then I've got two, but you ought to be able, as far as I know, you ought to be able to work in the very first one. Let's see. Okay, let me just put this down in the corner. Maybe I won't lose that. So here's my information. If you need any help later on, I won't be reading email while I'm teaching. So basically, a little bit of background on Python. Python is a general purpose programming language. Way back in the day when I first started hearing about Python, they talked about it as a scripting language, and you just used it to script things. But now it's a very general purpose language. A lot of schools are even using Python as their first programming language because it's so easy to learn the syntax, and it's a little bit easier than dealing with Java, although it is object-oriented, as we'll find out. I'm going to tell you that this was created in 1980 by a gentleman by the name of Guido von Rossen. He is, that's not how he pronounces it if you see him on any of his talks, but that's as close as I can get. The pronunciation is in his home page, and there's a link there if you're interested in reading about him. He's a very interesting gentleman. Python is very intuitive and it's minimal coding. The syntax was made easier to deal with, so there's not quite as much to learn when most of the errors come from your logic rather than syntax. For intro students, it is object-oriented. It's interpreted, not compiled. What that means is typically in your C, C++, Fortran, you save the code, you interpret it, you run it through the compiler, and it creates an executable file. In Python, each time you run the program, each statement is interpreted during runtime. So that makes a little bit of difference. One of the things, and sometimes I think it's wonderful and sometimes it's a real pain to me, is that it's dynamically typed. So you don't have to worry about creating type declarations. If if you want an int, you can type x =7. And when that Python interprets that statement, then an integer is stored in x with the value of 7. So that's pretty cool there. The data type, which means the data type is tracked at runtime. It has automatic memory management, unlike C, so you don't have to worry about collecting your garbage as you go. And be very careful to remember that spacing is what defines blocks of code, such as your if-else, your fors, your whiles, your functions and modules. So you have to get that spacing correct. When you are doing block of code spacing, you always use the tab. You never use the space bar. And I will try to repeat this multiple times. So why should you use Python? Well, it's one of the easiest programming languages to learn and prototype in. It's very quick to learn, minimal time to develop and maintain codes. It's very modular and object-oriented. It has a large standard and user-contributed libraries. And I thought I fixed that that spelling there. And there's a very large user community that you can ask questions of. Couple of the disadvantages is it's interpreted, which means it's slower than compiled languages because you're going through the interpretation at the time the line is executed. It has to go from our English to machine language. And it's not great for 3D graphic applications. IPython is a shell, a command shell for Python written by Fernando Perez. And that's what we used to use instead of Jupyter Notebook and all of these other fancy things we're using. It's got all of the same functionality as writing code on the command line, but instead of having to write the entire program, you can write your function. Whatever is defined in the command before or in the block before is still defined in the next block, as long as you don't leave the shell. So that's pretty cool. It has command tab completion. It has color highlighted error messages. So it's very easy to use. And it's great for plotting. And there's a link to ipython.org for more explanations. Jupyter Notebook, which is what we're using today in Colab, is a web interface to Python. And because we have the web interface, things like Google Colab, we're able to take advantage of that. And I'm not going to say a lot about that because you're going to learn that as we go. But there are many, many web libraries that we can use. We use all of the Python modules and libraries, and it'll allows you to interface with other languages as well as Python. So now let's talk about Python itself. And I am assuming here, and yes, I do know what happens to you when you assume, but I am assuming here that everybody has some basic programming experience. A variable is the name of a location in memory or in storage that is dynamically determined, type is dynamically determined from the value it's assigned. It's just like a variable in C or C++ or Fortran, pretty much. So be sure that you assign meaningful variable names. as part of the debugging procedure. If you're hunting for a particular thing and it's just var 1, var 2, var 3, var 4, you're going to have a little bit of trouble. Like any other programming language you've used, some keywords are reserved for the language itself. And here's a reference to the keywords that are reserved. They're not a lot of keywords, but you need to know what's what. And you assign the string, you assign the value to a variable pretty much like you do in any other language. So we're going to go through that. We have typically the same arithmetic operators, plus, minus, slash for divide, equal sign, greater than or equal to. We have the Boolean operators, comparison operators. They all look pretty much like the same thing. So now we're going to come back and see what this looks like. The numbers 1 and 2 are line numbers that are automatically assigned by Jupyter Notebook. So don't try to figure out what they mean in Python, because they don't mean anything in Python. I have x equal sign 3, or x is assigned the value of 3. If we were all together in the classroom, I'd ask you what you thought that meant. But since we're not, I'm going to tell you that x is assigned the value of 3 means the integer 3 is stored in the memory location that x points to. Type is a function that tells you the type of data that's stored in that variable. It could be an integer, a float, a string, a complex number, several other type of things. So the first thing that happens here is I am going to, and you can hit, and the first time you do this, because it came in from GitHub, it has to warn us. And the only output we get is int, because we're simply asking what type it is. We come down here, y is assigned the value of 3.0. For those of us in the know, 3.0 is a floating point number, and so y is of type float. And if we run this, it comes back and tells us float. So far I'm telling you the correct things, and I'm not messing you up. Here, z is assigned, let's do this. Z is assigned a string, HELLO, hello. And if we run this, and I'm using shift return to run it just because I'm used to doing that, we get back type string. So like any language, here, int is a function that changes whatever's inside the parentheses into an integer and returns an integer value. So 3.3 becomes the integer 3. Here we've got complex and a 3, so it's going to show us the complex variable that the 3 represents there. And I'm trying to keep an eye on the chat in case, but I hope I'm doing this well enough that you all don't have any questions. Import, in C and C++, you use a number sign or hashtag include, and then you would have math.h. And these are the non-built-in functions that you want to call in to do just regular math. This does the same thing in a Python program. It imports the math module so you can do the square or the absolute value. So shift return, and it's not going to return a value because it's not printable. It's just simply importing it into the program space we're using. Now that we've done that, we can get the absolute value of -3.3. We can find the sign of 60. Now notice that absolute value, that's a built-in function. If we are using anything from the math module, we have to tell it math.sign. So that's something we all need to keep our, and apologies, I added a new line. I forgot to hold shift down. So the square root of 25 is 5. Any questions about variables and numbers? Okay. So now let's do a little workout with strings. Everybody get your brain muscles working. The variable myString is assigned the value of the string hello world. Now remember that Python, like C and C++, starts indexing at 0. So as we move along, you'll see how that works. So for myString hello world, shift return, it runs it. It does not return anything because we're not printing or writing. We are just storing that in memory. On the next line, we have print, which is how you print out a result, the value that's in my string, okay? So it's going to print out hello world, and then the length of my string is 11. Why is it 11? Well, count the characters that are stored and you'll find that there are 11. So we want to get the length of my string, that, and we want to print the length of my string. And once again, I've reminded myself to say it again, indexing starts at 0. So if we print my string sub 0, what do you think you're going to get? What's the very first letter in hello world? You're going to get an H, a capital H. If we print 1, you're going to get a lowercase e. And if you print 10, what are you going to get? Well, there you go. You get the D. Why isn't it 11? Because we started at 0. So you go 0 through 10. String slicing. String slicing is when you take certain partitions of your string without taking the entire thing. Here, my string sub 1 to 4, it will give us E, L, L. So it will run through a basic loop that prints out starting at 1, and when it ends at 4, it will print out 1 through 3. Here, if we print this, we should get the entire thing. So, and here, because it starts at 1 and it does not have a value telling it to stop, so it goes to the end of the string. If you can't, I'm sorry, if you can't see my hand gestures, you're probably not getting everything because I explain with my hands, and I apologize for that. So 1 through 4, 1 until 4, not through 4. 1, 2, 3. Hello world with no boundaries gives us everything, and hello world with a boundary at the start. We start at this location and we go to the end. Now we're going to split it. Splitting is different from splicing because it will actually put it in another location. The splits in another location if you set it up right. Here, my string split is going to give us, and you notice this keeps coming up. It's going to, this is your object orientation. It's a built-in function for the class, and it's going to, at this point, it's going to go until it hits a non-alphabetic character, till it hits a space, and put it in the first half in S1 and the second half in the S2. So, so if we print S1, we get hello. If we print S2, we get world. And if we print both S1 and S2, it looks just like we printed the entire string. And if you've got strings and it needs to span multiple lines, you notice that we've got 3 sets of double quotes on each end. And what this is going to do is going to print out, this is a multi-line block of sample text, but it's going to print it out in the same order as it was saved in the line. It saves the line spaces. And here, formatting strings. If we're farmers and we're keeping track of pigs in the barn, I might have sold some of the pigs might have had babies. Whatever you do with pigs on a farm. So, but the number in the barn might change every day. And our farmer has a sense of humor. I won't say whether it's good or bad. So %D says, this says go over here to this container. The first location, the first item after the % open paren is going to go in the first location, as long as it's the correct type. So 300 pigs in the barn, aisle %S is the second time we've found the formatting. It comes over here, it gets puff when it's printed, and another string, it gets puff. So shift return, and look, I told you correctly. So another example of string formatting, I've got this string my share is a floating point number, tip a decimal point number. The percent 0.5F says that they're going to be 5 digits after the decimal point. So if we wanted to print it out like we normally print money, we would tell it to. And the tip says that I want to print whatever comes in here as an integer because there is no decimal point. So we're going to come along here. 1, 2, 3, 4, 5. 0.5. It printed all of these zeros. And here, instead of 5.5, we got 5 because it said print a decimal point. So, unless I had a guest, I've got my share of this dinner here, and I'm going to tip the wait staff $5, and it just prints that out. Other string ops that we can do, let's put hello world in my string. This is a true-false statement here. It's asking, is what's inside of my string all uppercase? Or wait, no, let's do this right. Okay, it's not true-false. It actually sets it to uppercase. I don't know why I always think that that's a true-false. Here, this is a true-false. It asks, is it alphabetic? And then it says, get my string sub-0, which would be the H, and is it alphabetic? Then we create the variable A with the value of 12 assigned to it. And when we print, is it a digit? So it's all printed in all uppercase. And it is digit is true. So let's go and look at our control structures. Like most languages, you have to have particular structures to control the action of the program. These are your if-else, your for and while loops, break out of a current loop, continue, pass, those types of things. So X is assigned the value of 500. If 500 is greater than equal to 5, we're going to put print greater than equal to 5, and then we're going to print height greater than 5. If it's not greater than 5, we're going to print less than 5. And you can pretty well guess exactly what's going to happen when we do this. $500 is greater than or equal to 5. So if we change this and made this 4 and rerun it, it's going to print 4 is less than 5. And I'm going to go ahead and change that back and come down here. Our first loop, the for loop, we're all pretty much used to doing this. For the number is in a range of 3, print the number. Well, that's what it does. It starts at 0, because unless you tell it to start at a different value, it's always going to start at 0. So it's going to print numbers in the range of 3, 0, 1, and 2. prints it 3 times. Now, this is a while. Remember, with the while, it's an event controlled loop. So you have to set it up. It doesn't automatically increment for you. Index is assigned the value of 0. While index is less than 3, print what's in index. And it does not increment automatically for you, so you have to do the incrementation. I forgot to mention this as we did the earlier control structures, but notice that at the end of the very first line, each control structure has a colon at the end. At the end of the line with the if, at the end of the line with the for, at the end of the line with the while, we all have a colon that says there's more coming. Then we hit tab to indent. Don't use spaces, use tabs, because that's what it looks for. And we print what's currently in index, or 0, and then we add 2 to the index. So it's going to come up here. 0 plus 2 is 2. 2 is less than 3. So it's going to print 2. And then it's going to add 2 to what's already there. So 2 plus 2 is 4. 4 is not less than 3, so it will stop. And if you do shift return, you need to be right here. And that was the result that we just walked through. Indentation signifies code blocks. So this is just dealing with prime numbers. N is assigned the value of 2. While n is less than 10, we set prime to be true. And then for what's inside x is in the range. This is, remember, the index x starts at 0 in range, except it doesn't start at 0 because within the range we have given it a starting point. 2. Go to n. 2 modulus arithmetic. That's your old longhand division where you have an integer remainder. 2 divided by 2 is 0. Then we have an else statement to indicate our code. Here, 3 is a prime, 5 is a prime. We're not making changes, so we get 7 is a prime and 9 is a prime. So we print every time that the prime is true, we print that there. And you notice we've got all prime numbers. Let's loop through a string. Instead of hello world, we're going to loop through banana, the string banana. And we're just going to print out the individual letters in banana. For loop, colon, print. And instead of using the word we want in a variable, we're just iterating through the string. Any questions? Just raise your hand, do a little chat thing. Another for loop. While x is in range of 6, print x. Everybody guess what it does and then run it and see if your guess was correct. It goes from 0 to 5, which makes 6 times through the loop. Once it got to reach 6, that's the 7th time, so it comes out of the loop. Range and increment by 3, so you don't have to increment by 1, that's just the one that's automatic. 4, the value of x is in the range of starting at 2, going to 30, and progress by 3. So we're going to print 2, 5, 8, 11. We increment by 3. If we started at 0 instead of 2, we would be counting by 3s. Three, 6, 9, etc. Let's talk a little bit about lists. List is a specific data type, just like int or float or string. It's where we would keep values like addresses and or lists of book names, or the values of the inventory and the name and values of the inventory in the store. We can modify it without creating a new object, but simply a collection of data. And it's just like lists in any other language. So we declare a list called my list. You notice the square brackets. In most of the data structures, you're going to use square brackets to start with. If we print out my list, we'll get 1294. If we want to know the data type, we tell it type and the name of the variable that we want typed. So shift return. And we can also tell that it's a list because it's got the brackets around the plain print. And this is the list. The word list is the result of type. Now, my list 2 is assigned list in the range of -4, 10, and 4. So the range is going to start at -4, it's going to go 10 times, and it's going to increment by 4. So -4 plus 4, 0 plus 4, and 4 plus 4. And that's what we get in my list. So what if we want to access particular list members? Well, it works kind of like strings did. It starts at 0 and it ends at n-1. If we print the first element, we would use print my list sub 0. If we print the last element, we would print my list sub 3 because we only had 4 elements. So 0, concatenate, glue together, my list plus my list is going to give us the values that are in my list twice. My list times 2 is going to give us the same thing. My list times 3 will give us the values that are inside my list repeated 3 times. And here we're going to use a for loop, and we're going to iterate through the list and print what's inside the list, one thing at a time. So for name in animals, where name is the 0th element, dog, when name becomes the next element, it will be pointing at cat. And when it becomes the 3rd element, it will be pointing at horse. And now we're going to look at a value called enumerate. And I can't say that it's something I use very often. Let's go ahead and get the values. So if we put Ford, Chevy, and Toyota in cars, it works just like we've seen when we print it. Ford, Chevy, Toyota. If we create a new list and say enumerate cars, it returns the value of cars with the enumeration. So 0 goes with Ford because it's the first one. 1 goes with Chevy because it's the second one. And 2 goes with Toyota because it's the 3rd element in them. And we printed this as a list so that we would get the enumerate values. And here, this is just printing out the values in the list and the enumeration. So what if we want to change what's in our list? Okay, first of all, we're going to delete my list sub 0, and then we're going to print what's left. Then we're going to append or stick on the end, add to the end a 99 and print my list. My list has 1294, I believe, I saw just then. So we put 99 at the end, and then we insert in space 1 the value 100. So let's see. Delete sub 0, the 1 was deleted, it's left with 294. When we append 99 and print it, 29499, when we insert 100 into the first location, not the 0, we get to 109,499. Everybody still with me?
I have a quick question.
Okay.
So I'm coming from a C-based language, so the notable lack of semicolons is kind of getting me here. Could you speak to like when they're used?
If we look up here, semicolon, well, even where we are, semicolons are used when you want to put more than one, to separate statements. When you put more than one statement on a line, is the main place that you see those. So up here, I've got delete my list sub 0, semicolon. This is the end of this statement. Anything else on this line belongs to a new statement. It was very hard for me. I got a lot of syntax errors when I first started using Python because I read through the book and I typed in the exercises and it was easy and it was great. But when I was typing my own code, I kept putting those semicolons like I would with C. And of course, when I code, I very seldom ever have two statements on a line because it's just part of documentation to have one statement on a line.
Okay, that makes sense.
Okay?
Thank you.
You're welcome. So here, we're going to sort our list and print it out. And then we're going to reverse our list and print it out. So 2,109,499 is what we got after our last insert and append was done. So when we sorted it, 249,99, 100. When we reversed that, just exactly what you would think. And here's some more sorting using strings: cats, sheep, dogs, horses. One of the things that you remember is that most computer systems use ASCII values. In ASCII, no, I don't remember a lot of values in ASCII. Space is 32 and capital A is 65. And those are the only two I remember. And I also know that lowercase a comes right after capital C in ASCII. So it's 27 differences from capital A. So if we do this, we're going to sort, first of all, based on the length. 4, 4, 4, 5, and 6. Then we're just going to sort it. Capital D comes before capital S. Lowercase c comes after all of the capital letters. Lowercase h would be sorted. So doing the numbering system the way they did allows us to keep things sorted the way we have been taught all of our life to sort when we're writing on paper. And here, horses, cats, sheep, dog, it's just the reverse of the way we sorted it before. Here, cats is 4, dogs is 4, sheep is 5, horses is 6, based on the length. And if we sort it this way, cats, dogs, horses, sheep. So just some basic sorting fun in case you need to sort in any way. So here we've got my list 2591. We want to square it. The list square is going to become x raised to the power of 2 for every x in my list. We've been seeing like code like this, sort of like this, but this is the increment that we would have. So 4, 25, 81, and 1 for square. Now for large, it's going to go through and it's going to print out And once again, we didn't change my list. So if it's in my list, we're going to print it out if n is greater than or equal to 5. There's only 2 things that are greater than or equal to 5 in that list. And I don't deal with strings enough that, yeah, I've sorted it, but I've never really had a reason in writing code for work to reverse it or by length or things like that, although it's cool that they have that there should I need it. So any questions about strings? Well, we're moving a little too fast here, but we'll keep. Well, as a matter of fact, I need to stop just a minute and grab a sip of water. Thank you. So Python has values called tuples that tend to be a lot of fun. In C, I think of them kind of like structures in C, which you can have in your list, because you can have in your list, you can have an element that is the name, an address, whatever. The big difference is that you can't change a tuple. They're immutable, but their values may change when, let me, okay. The values may change when one of the structures inside the tuple is mutable, like a list or a simple integer or float. So there's a picture that I forgot to put into the repository that refers to Tweedledee and Tweedledum, and they have a birth date that is the copyright date of Alice in Wonderland, and they have a list of things that they like to do in there. Here is a very nice article. The one article that made a difference in my understanding why you would want to use a tuple and how mutability works. And here's the tutorial on Python tuples that but those, I went through this one first and I still didn't quite get the hang of it. And so then I went back through this list. I mean, this article, and just oops, sorry for the commercial. You can see the picture from Alice, and I guess most of you would hopefully recognize them as Tweedledee and Tweedledum. And so Tweedledum was born in 10/23/1861, and so was Tweedledee, which makes sense because they're twins. Both of them love poetry and pretend fighting. Well, who didn't when they were kids? And then it comes through and it shows us the picture of them changing the values. Notice that when we say is dumb equal to D, it's true. Is dumb and are dumb and D exactly the same? It's false. Why are they false? Everything is the same inside. Well, because they were declared separately, they have separate indices, separate object numbers. Now we create a value T doom, who is based on dumb. If we ask it to print the values, it's the same as dumb. T doom, is it equal? Yes, it has exactly the same in it. True, just like before. T doom is dumb. True, because they are the same thing with the same object numbers. Now, if we go into T-do and we append rat, because he likes rat, notice when we print out the values of dumb, rat is also there. That's because they're the same object. And so if you think about it this way, dumb has a birth date. T-do, because it's the same object, has the same birthday. They both have the same skills. So when you get confused about that, you go back and look, and then you can work through examples just like this using the tutorial provided here. Because part of it is the more that you deal with something, the more comfortable you become with it. Okay, we're going to create a tuple and print it out. It doesn't have anything in it because we didn't assign anything. Now notice that in tuples, unlike lists, instead of square brackets, you have got parentheses. If you put something in a tuple, it has to have the comma to work, even if you only put one item there. Now here's a tuple with multiple items. We'll print it out and it will print 2831. Then we will assign the values inside my tuple to the variables A, B, C, and D, and we will print what's inside of A, B, C, and D. So our tuple looks just like the declaration of my tuple, and when we print out the values, we print out the integers 2831. Here, if you want to print any individual item from the tuple, you tell it where you want to go to get it. Tuple sub 0 is the very first one. Last time I taught this, I wasn't paying a lot of attention, and so I spent a lot of time looking for syntax errors. So I have a tuple. I put physics in it. I put chemistry in it. I put 1997 and 2000. When I print that out, everything that's in it gets printed out. Then I delete it. And I get a syntax error. Okay, and we have all of this. And it says here, Name tuple is not defined because right after I printed it, I deleted it. So, and I tend to panic when I get something incorrect in front of a class. So I have to warn myself, oh, I'm doing this on purpose. Now, immutable or not, and here's exactly what we saw before. And yes, I did write in and get permission to use this. Here I've declared these two variables, these two tuples, dum and d. Are they equal to each other? They have exactly the same things inside of them, so it's true. Are they exactly the same thing? No, they aren't. Why? Because they have different ID numbers. Create a new tuple, giving it the same information as in tdum. But not only does it give it the same information, it gives it the same ID number. So if we do, are they equal? It's true. Are they the same? Yes, it's true. Why is it true? They have the same ID number. If I want to find out the skills that any one of the three have, I can tell it to go to the skills portion, sub 1 of the tuple, and put them in the variable skills. Then we print skills. And that's going to print this location. Now I want to add wrap at the end to skills. So here we go. Have to click on it first. So line 1, poetry, pretend fight. Line 2 is printed out. Line 4, add wrap to the end. Print tdum, print dum. They have the same information in them. And now dum and d are not equal to each other because dum has one more element in skills. Any questions here?
Cassie,
Yes.
we might need a longer break because we see a few questions coming from the chat window.
Oh, okay.
Yeah. So I think now it's 10:40. We still have sufficient time. How about we take like a 10 or 15-minute longer break?
Oh, I'll be glad to take a 15-minute break, and I'll look at the chat window and see.
Yeah.
Oh, I thought y'all were going to interrupt me, so.
How about we, yeah, I will first let the attendees work on the notebook a little bit, and we can go into the break room for a short discussion.
Okay.
Yeah. So we'll see you in like 10 or 15 minutes.
Okay, sounds good. I guess because I left my chat window open, it didn't tell me there were more questions. I apologize for being a bad presenter. Okay, so did someone answer Ephraim's
Yeah,
question about where's the
some questions are answered.
okay,
Let's first go to the break room, and we'll see
okay,
you in about 15 minutes.
okay. Then I'll take a break too.
Does anyone know where the break room is?
Nope.
Okay.
In my experience, break rooms are typically teachers only, so I guess they're getting away from us.
Okay. Okay.
But that was a joke.
Got me. You got me on that one.
Hi guys, just to make sure that everybody on the same page. So we are in a break. Kathy will return in a few minutes, so it's okay to work around, stretch our legs. You know, we'll be back soon.
Okay, we're still on break, but I'm back. I apologize, but I accidentally left my chat window open, so I got no new messages because they were counted as soon as they arrived for anybody that might still be there.
How did you correct the defining error for TDOOM and DUM that you went over earlier?
Oh, okay. Okay, so the defining error. Okay, take your wet dog. Okay, the defining error. Which one of these?
I'm not entirely sure, but I tried messing with the code a little bit later, and it said I had a, what was this? That's not line 8.
Can you tell me what the first line of code in the section you're working on is?
It's 107, so it's tdoom equals dumb. And then it has a name error, name dumb is not defined.
Okay, let's see. I evidently did not turn on my section numbers. So dumb and
That's
D.
the section below that one, tdoom equals dumb.
Okay, tdoom is assigned the value of dumb.
Mm-hmm.
It helps me logically if I say it that way, so I know what's going on. And we got an error in.
Well, I think you fixed it. I don't know.
Hang on, let me.
But
Oh, well, where's the one I'm working in? Okay. Okay, y'all don't watch, you'll get dizzy.
oh,
As
okay,
I
good.
scroll through this real fast. Files. Okay,
I
here we
think for
go.
some reason there was this extra space where the 3 is.
Okay, and one of the things, somebody kept saying that they had problem with the notebook, and it will come up and say this because you're running it from GitHub, and you always tell it run anyway. Now, what line did you have the extra space in?
107, so it's the one where you're at right now.
Oh,
I think
okay.
it's, for some reason when I ran that code, it said there was a naming error, that dumb was not defined, but when I got rid of the third line, the space at the third line, for some reason it worked, so I'm not entirely
Yes.
sure
Okay.
why. Now it's just randomly looking now. Yeah, that's weird.
Anybody else while everybody's on break?
Hey, yes, this is Sherilyn Davis. I had a question about the prime number.
Wait. Let me turn my, because I couldn't hear you. Try again now.
Oh, I had a question about the prime numbers. I noticed that it was, I think someone else noticed it in the chat, but the prime numbers, one of the numbers is 9, and 9 is not prime, so I don't know if something's wrong.
Let's go back. I went
Yeah,
back
so
to,
Kathy, there's an indentation issue with your loops that's causing it to,
and that's why I don't like indentation. Okay.
take that space out of prime, you'll find it.
Oh,
It's
thank
in the
you.
control structures.
Oh, yes, control structures because it's inside a loop. So that's a good hint. More sorting.
I think you need to search for the indentation keyword.
It's right there. You have to open up the cells.
Control structures, hidden cells.
See, I don't usually hide those. Okay, because then I miss them.
Cassie, I think this is an easy fix. It probably just copy, if you uncomment the line 12 to line 14, that should fix it.
If I uncomment.
Comment line 12 to line 14. Comment it out, comment it out. And you need to unindent line 9 to line 11.
Yeah, that's indented too far in, out, whatever.
Yeah, it should be the same level as the 4.
Yeah, that's
Unindent, yeah. Yeah.
No, I just want to make sure.
It's aligned. For that if, you need to undent the same level as the 4. So 2 spaces to the left. Yeah. No. Yeah, that's right. If you run it, that should be 2, 3, 5, 7. You should be able to run it. Yeah. I should fix it.
Yep.
Can I ask a question?
Yes.
The on tuples, you cannot do ranges.
Okay.
I see that you have a tuple here where you are doing ranges, but for some reason when I tried it, it's refusing to do it.
I'm doing ranges. Let's see.
Can I show you my screen for a moment? I'll show you the problem I was getting.
Okay.
Oh, I can't do it.
Yeah, the host has to. Pass it to you.
How about we solve that? If we do want to see your screen, can we do that in the afternoon in the break room?
Yeah.
Okay, but there's also another easy way to do it. For example, I can show you on chat. So if I do this.
Okay.
If I do this, I get an error. Let me run it and I'll show you what I'm talking about. I'm getting an error like this. Let's see. So this is the same example that you did, just a little different naming, but it seems to be complaining about using the range 0 to 3 on the tuple.
Okay, let me see.
I would suggest for
because
these,
it's not a list.
So you cannot use ranges like, but I saw in one of your lines that you were using, of course you were using comma, you weren't using a colon. So let me just try that and see.
Colon means?
Yeah, it means a range.
Yeah, colon, I thought you said comma, and I was like.
No, you were using comma, which is a list, But if I try to use a colon, it doesn't work. So let me try this thing here.
Oh, okay.
It's telling me that tuple object is not callable.
Right.
So I tried this.
We have one tuple, and it has 4 elements in it.
Yes.
So if you are,
So if I try this, let me show you. So if I try this, what I get is this.
okay, if you look, if you just do the basic assignment, it's an invalid syntax, and I believe that let me just make sure it's not.
It shouldn't be that.
Okay, so I think it uses, the only thing I can see there that's wrong is that it can't do that because you're saying
No,
to it use the elements.
Are you using the parentheses instead of the brackets? If you're using the parentheses, it's you are like calling a function, and that's not going to work. You need to use the brackets, square brackets.
What I did was I tried to assign the list A, comma B.
Yeah.
To the tuple range 0 through 3.
Yeah. So let me print
But
a
you can't
list.
use range on that.
How about this? Let me print the correct code that will work in the chat window, so it will help you. Give me one moment.
But that's a range, so you can use.
So this line should work at tuple equal 2, 3, 4, 5, and you need to use the slicing. Does it answer your question? You cannot use the parentheses. You need to use the square brackets.
Which basically treats it as an array.
Yeah. This is actually
square brackets make it a list.
Yeah, it's treating it as an array basically. If you do it that way, it's just curious.
You're basically indexing or slicing that. Otherwise, if you use the parentheses, it's calling a function. It's not going to work. All right. For details, I would suggest we go to the afternoon breakout session.
Okay.
Yeah, each one will have 2-minute questions. We currently have 104 people. So we won't be able to answer all the questions at this moment in the lecture session for every question. So that's why we prepare the afternoon breakout sessions. All right. So I think it's now 11:06. Cassie, how about you keep continuing with the lecture?
Okay, so we just finished with the tuples. I know there are quite a few people that have questions about those.
Yeah, there's a question if you have a detailed, especially for detailed questions like that, let's do it in the afternoon.
Yeah. We can always go back through it again and deal with that. Dictionaries are a cool data structure. In C, you would use a try to create a dictionary structure, but it's a list of key value pairs. And way, way, way back in the old days when we were doing Fortran, this is how we created, before databases became a really great thing. This is how we created like inventories. You'd have an item number and a description and a cost and a retail cost and so on. But this is, you know, you go to a dictionary, you have a word, you have the meaning and pronunciation and everything. So it's just a key value pair, and it's unordered, it's not indexed. So you can't go by 0, 1, 2, 3. You have to deal with the key, and you have to know what those keys are. Oh, I didn't ask, is everybody back? Fung, is everybody back?
I think so. We have 1 or 3 people. Yeah, I think please
Okay.
go ahead.
Oh, yeah, I see that there. So anyway, the data types are heterogeneous, unlike the list, and the element is accessed by the keyword, not an index, and the elements are changeable. So you have a dictionary, and you think of it as key 1, value 1, key 2, value 2. And there's another tutorial there that I found very helpful, and realized it was like when I used to teach my C students when I was teaching over in computer science, and we were doing this. It's like, oh, okay, I can do that. So I'm declaring the variable my dictionary, which tells me as part of my documentation that this is supposed to be a dictionary. Cats, the thing in the string, is the key. Cats, dogs, sheep. The thing to the right of the colon, and you can also say the thing to the left of the colon, is the key. The thing to the right of the colon is the value. And so if we print this out, it prints it out just like we saw it up there. If we say print my dictionary for the key cats, it's going to print out the value 4. Here it says access the variable my dictionary and print the value for key horse. So we come up here and we search for horse. Did I leave horse out? Did I delete that? I assigned that value there. Excuse me. I read that statement entirely wrong. So I want to access my dictionary. I want to add the key horse and the value 3. That may be too big for you all. I apologize. I've got to be able to see it. And then I print the sorted value for my dictionary with cats, dogs, horse, sheep. And then we're going to print the keys separately. And then we're going to print the values separately. And I think when I was goofing around down here, I deleted that line. Oh no, here it is. Print my dictionary values and then print them sorted. So just print the keys, just print the values, then print the sorted values. And that's why I typically use one line for every statement. And the last thing in dictionaries is for key value in my dictionary items, print key value. So it's just a little for list that goes through and prints the entire dictionary. So do we have any questions there? For those of you that haven't done a lot of programming, it's simply a way of storing items so that you don't have to know the name of the item or the value of the item. You know a key value. And these particular exercises were created to get you more comfortable with thinking of, I know the keys, I search for the keys, because the way you're going to use this is as a flat file, which is what we called it before we had all these wonderful hierarchical databases. And it just gets you used to thinking in that terms of things. Cats, dogs, sheep, horse as keys don't make a lot of sense to me, but it's an illustration and it should bring it home. Any questions?
So Kathy, I'm wondering why the print sorted my dictionary is different from the print on my dictionary. So it's not printing the whole dictionary, it's only printing the keys.
Okay, hang on a minute. Line 60.
56.
56, okay. Well, everybody has.
Oh, yours is different.
Yeah, I've got different numbers. Okay, my dictionary.
Yeah, it's 60.
Okay.
So why after sorted my dictionary is only printing the keys, not the whole dictionary?
Because the keys are the only thing you know. I went and looked that up. I'm trying to remember what I read, because every time I do this, any of you facilitators know off the top of your head why the keys aren't printed out here on the line where you append horse and the value 3, and it just prints out the keys? I mean, the basic reason is that's the way they wrote it.
It's okay. It's okay, Kathy. Thank you.
Okay. Now you've got me. This is too many keywords. No. I'll have to go play with it
I believe
this afternoon.
yeah, I believe when you do sorted lists, sorted dictionary, the sorted the values are those results. They are sorted based on your keys. Is that correct?
Right. You
So
have
that's
to
it.
sort it based
Yeah,
on the
because
keys.
when you sort it has to be based on your key. So when you sort on the keys, it will print out the values only.
Okay, thank you.
Yeah, that might be an answer, but I'm not 100% sure.
That's the one that makes sense to me.
Thank you.
Yeah.
Okay, so how do we, because most of you are doing some kind of research and you're going to use files, you're going to open a file, you're going to read the data from the file, you're going to do some kind of calculations on those files and store them in an output file. We need you to be able to know about files. So if I have a paper file in a file folder in a file cabinet and I need that data in that file, I'm going to open the drawer and I'm going to pull that file folder out. I'm going to open it up. I'm going to read through until I find what I need or until I get to the, given that I have a photographic memory, I'm going to read through to the end of the paper so I have all of that information in my brain and I can do something with it. Once I finish reading it, I close the file and I put it up. So, and you know, it's pretty much the same with writing, except instead of reading, we're going to write. So we can open files, we can close files, we can read files, and we can write files. We have to have a separate mode for each one because we have to tell the computer what to do. So to do anything with a file, you have to open it, just like in that example. On a computer, we tell it, we have the command open, and we give it the file name and what we want to do with it. And if that file exists, it gives us back, it puts in this file handle the location of the first element, first character, first number in that file so that we can go there and move through it. And the file handle has two things in it. It's got the location in memory where the file is, and it's got the location of where we last stopped in that file. You can append to a file, just like in my file folder. If I have new paperwork, I put it at the end, so it's in my file. I can read it only. Typically, if you're just getting your data out to do calculations with or to print up a report, it's going to be read only. The less that, and hardware is really stable nowadays. But back when I first learned to read and write files, they were on magnetic tape. I started school at 26, so I didn't get to use paper tape. I used magnetic tape, and then very shortly after I used magnetic tape, I used magnetic discs. But the hardware was unstable. If you bumped into the disk cabinets and it was not a solid disk cabinet, you could actually make the read-write head scratch the disk or the tape if you kept the head on the disk. So one of the things the teachers would come around and thump you in if you didn't open it, read it, and close it. Open it, modify the file you're doing, close the file, modify the file you're using, save that and then write it out. You never ever kept a file open unless you were writing to it. And you didn't do any calculations if you had it open for writing. You just stored it on in memory, and then you open the file for writing and wrote it out. So you can add at the end, you can read only, you can write only, and you get an error. It puts like, I'm not sure what Python does, but C puts a null for the address. And when you get that null, it returns that null. And if you try to write, it tells you that there's an error because the file doesn't exist. You can read and write, and with an R plus and a W plus. And sometimes that happens. And then there's something called a binary file. And you use binary files so that with a binary file, it's created in binary blocks. So if you want to jump through, files are typically read sequentially, one block after another. And you don't know exactly how long that block is, but a binary file has a block that's the same size, whether all of the data exists or not. And that way, if you need to go to a particular location in that file, it will jump there. So anyway, the big trick about binary files is if I create a binary file on my Mac at home and I send it to you and you try to run it off of Supermite, you can't, because my binary file will be different than yours because of the different hardware and hardware rules. Anyway, Python has a built-in garbage collector, so once we release a file, once we close a file, the place in memory goes and gets that memory and puts it back in the heap so you can use it over. And so it's reclaimed. Now, we're going to do an exercise to read a file, and so we don't have to go and type something in. We're going to use a command line statement that says, if data text exists in this location, we're going to get it from the 2018 workshop. And we're going to write it. And then, so let's everybody execute this without changing it. And this is what you should see. And the big thing is, and it tells you what it's doing, but the big thing is data text has been written 100%, 630 kilobytes in 0 seconds. And so it was saved. That means we can do this next one. So we're opening, where input is our file handle. It's where we're going to keep the first element, the location of the first element in data text, and where we currently are in the file. We're going to open it for read only, and we're going to read that entire file and store it in the variable content. Then we're going to close that file, and we're going to print everything that's in content. And once again, these input, read, input, close, these are functions that are built into the class of files. And so we can use it to access the object file. And this is just from Academic Press. It's some data from a survey that people are using as data science example. And so we printed everything that we read in and stored out. Any questions about that? Yeah, in the if statement, right after the 1, there is an exclamation point or a bang, and it escapes to the operating system. Any other questions before we write a file?
This escape, is it just for this environment, or does it
Yes.
work everywhere?
Well,
Can you be more specific about your question? So
yeah, the escape.
I know what he's asking.
Yeah.
He's asking if the bang symbol will work in Linux, but it's a command. It's a magic. They call it a magic magic something for Jupyter Notebook, and it allows you to escape to the underlying
So it's
operating
specific to that
system.
environment then.
yeah, because the current Jupyter Notebook, or say the Colab notebook, runs under a Linux environment. So when you use the exclamation sign, after that, it executes a bash command, which is a Linux command.
Yeah, I tried this just a moment ago and it didn't work for me.
Are you using the Google Colab notebook or using something else?
Like I said, on the Google it does work, but on a Linux system, like Ubuntu, for example, or anything else, it wouldn't work. It doesn't seem to work. It gives me an error.
Well, I think for this particular setting or particular command, because we are using a notebook, that's why we put this particular bash command over here. For your specific environment, I would like you to discuss in the afternoon breakout session.
Okay.
Yeah, but Jupyter Notebook calls it a magic command, and it just does this magic that escapes you. But no, that doesn't necessarily, you wouldn't put the bang in front of that line. You would just copy the if to use in your go from the if to the end to use in your plain Linux environment, because Linux doesn't know what that bang means in that context. Okay, so if there's nothing about opening and reading a file, let's create a brand new file. So this input and output names there are just good documentation. At this point, it's a file name that we chose. I could have called it Charles there. I could have called it Bobby May up at the input one. But for documentation, it's what we're doing. So we're going to open a brand new file called write.txt, and we're going to open it to write to it and create it in this case. If we wanted to add to, we would use the append that we talked about earlier. Once we get it open, we're going to write the string writing to a file using the output.write function. Then we're going to close that file. And ls-l is a Linux command that lists all of the files in the directory that we're using. And we use the bang to get out of the Jupyter Notebook and go to the Linux command line. And so what happens is The dash L says write it as a list. So it comes one below the other. And so we've got data.txt, which we moved over. We've got sample data, and we've got write.txt, which was created on June 1st at 1632. And notice data.txt was created at 1625. Okay, so if we wanted to see what was inside it, what's inside it is exactly what we expected. It was the string writing to a file that we said write to this given file. Any questions about writing to a file? I know this might, if you haven't programmed before, it might seem kind of like magic. I actually typed key punch cards for 2 years before I started my, and that's why I wanted to be a computer scientist, because I could almost understand the Fortran and COBOL, and oddly enough, Pascal cards that I was typing, but I was so curious. Let me tell you, this is easier. If you're ready, we'll move down to functions. So a function, we've been calling functions like output.write, output.close, output.read. Output is the part of the class, write and close and read are part of the class they belong to. And output, of course, is the names that we created that are assigned to files. With functions, we're going to write new little pieces of code that we can call over and over again within a program, so that we don't have to write the same 100 lines of code 20 or 30 times within a program. So are there any questions about what a function is? Oops, I missed a bunch. Okay, most of that's talking about running things in Linux, so we're not going to talk about that anymore. So the pattern for writing a function is you have to tell Python that I am defining a block of code. It has this name that I make up. Once again, make it applicable to what you're doing. Don't call it Tom, Dick, or Harry. And I'm sending these values in. Typically, when you use functions, functions return a value. Now, it may just be the value that said this function ended successfully, or the value that said this function didn't end successfully. It may be the value that you're going to use back in the code. So we'll have to do this as we move along. I'm going to unhide my cells. And in the middle, here's my colon. Remember, when we are defining our own bodies of code, it ends with a colon, and then it goes through the code. And how many lines are in that function or in that body of code is determined by the indentation. So I'm going to write a function to do addition. I'm telling the system that I am defining my own function. I don't want to just use the plus operator that's already there. I'm going to call it my add, and I'm going to send in two numbers that in X and Y, one each in X and Y, that I want to add. Here, this says, okay, there's more lines coming, and it belongs to this function. I have my tab return. This return, like definition, is like define, is a keyword that says I'm sending this value back. And so if I send in a 1 and a 2, the return statement would come down here and it would put 3 inside of sum. Here I'm sending in 3 and 8, and it's going to put, if I do my math right, which my arithmetic right, which I typically don't, but sum is my name for the variable that's going to hold what the function my add returns. So this says sum is assigned the value from my add, and I send it in with 3 and 8, and X gets 3 and Y gets 8, which makes 11, and then I print the value. Any questions about that particular, why that's a function, why I had to do it that way? Okay. Now we want to return multiple values in our function. Once again, the keyword define, you have to have that to make a function. The name of the function, which is at your discretion. I called it power because I'm raising it to a power. I have input. Return input times 2, not times 2, I apologize. Input squared, input cubed, raised to the power. Here, power 3 returns 2 values, so I'm catching them in square and cube. And then I'm printing them out. So one of the things that you typically find in functions in a business would be the cost of an item you're buying, the sales tax of the item, and the total amount spent. You wouldn't have to return the cost, but you may have to return this amount of the sales tax, and you definitely would want to return the total. So that's why you would have multiple coming back. You can also send back the more advanced data structures. So I sent 3 in and I got 9 and 27 back. Any questions about that? Because that's something you'll be using a lot. Okay, modules. So it's a Python script that has one or more functions and statements that allow you to do specific work that you couldn't. When we, at the very, very, very beginning, one of the things we did was import math, okay? And that gave us the ability to calculate the sine of an angle, to calculate pi, to to lots of different math, more advanced math rather than just arithmetic. That's pretty well built in. So 3 of the things that are built in are math, the system, the sys, and I'm not sure what that does, and the OS, which has a lot of cool things. NumPy, which is a really cool module for those of you doing scientific calculation, and SciPy, which is based on NumPy, but has many, many scientific algorithms, and it also has some abilities for plotting. And I think this is supposed to be pandas. Then you have Matplotlib, PyPlot, and PyLab. And Matplotlib and PyPlot are in SciPy, I know, because we use that in my summer camp PyFun. And here's a reference to the standard libraries that we have access to. So let's look here. Import a module. We've already imported and used math. It's simply the keyword import and the name of the module that you want to import. And then I want to use sign. Want to find the sign using math.py. And so we don't have to calculate that by hand or look that up in an old mathematical reference book, which is what we used back before we had calculators, and print that out. Now, if we're not sure that we are, what module something is in, we can tell it dir and the name of the module, and it comes across and it tells us the functions that we have access to. Cosine, sine, tangent, ceiling, degrees, factorial, floor, just lots of different actual mathematical functions that are used in higher level calculations than basic arithmetic for sales tax. If we need more information, it's help math. So if we run that, it looks a lot like a Linux man page. I'm trying to go slow so I won't make anybody sick on their stomach here. But this is what a Linux man page looks like to a certain extent. Help on built-in module math. The name of the module is math. This is always available. You might have to load it. And here's a description of what each function returns. And everybody don't look at my screen because I'm going to move up down a little bit quicker. So if we need information on the range module, here's all of the information they have for us on how range works and what we can do with it. Class range of an object, information there, different things we can use with it, different things it will return and let us do. So it's just basically to help you get started with what you want to use. If we import OS, Ah, look, there's your bang ls that we used. If we import OS, we can use OS list directory, and it's going to look just like what we did. So data text, sample text, write text. That's what ls gives us. OS lister gives us the dot files that Linux uses that you can't see without the ls-a switch. And then data test, write test, text, and sample data. And here, display directory, we write a file, write a function, excuse me, to return a list of the files using the OS lister, and then we can process through that to display. So those are just, that's just one of the modules that we can use to, and in this case, a shortcut. Any questions here? And our last section before the lunch break is called data processing. Basically, we're going to import matplotlib.pyplot as PLT. We don't want to have to keep typing that over and over and over again. We set up the labels for the x-axis. We set up the number of ticks for the x-axis. We set up the numbers that we need. We set the plots for the error bar, the plot bar, the title, the labels, and then we show that particular plot, which is, as the comment says, a basic bar chart. Must have hit caps lock instead of shift. And so sale by month, sale month, you've got the Y ticks, the X ticks, the X labels, the Y labels, and then based on the information that we send it, it creates the bars. And the thing is that Python, like C and C++, have so many really cool things in there that it's as much work to find the one you want to use as it is. I mean, it's not as much work as it is to write it yourself. If you've never done that, believe me, it's not. But and it's very handy. But you do have to take the time to determine exactly what you want to present, how you want it to look, and then call the right function. And you notice we had to describe it. I mean, the colors, how thick it should be, where it should be. that type of thing. But when I first started programming and learning to program, you just couldn't do this type of thing. So it to me, it always amazes me. And any questions here? Well, this brings us to the end of my presentation. We've got some examples we're going to work on after lunch. So Fung, if you want to give us our directions now, we would be happy to hear them.
I think, did you give the exercise or examples in the repository already?
They're appended at the end.
Okay.
I've got a couple of others I'm going to add that are a little more complex, but I just haven't added them because it took me till last night to decide what I wanted to use.
Yeah. I think what we can do is we will stop the current session. I will leave the Zoom conference on, so everybody will go back to lunch, and we'll see you back at 1 o'clock, and we will use breakout rooms for discussion of your specific problem regarding either platform related, like how to open the Google Colab, you still have an issue, or you have problem with detailed question regarding how to understand the language or the examples. So we'll work on that. How about that? So I will see you, we will see you at 1 o'clock in the afternoon.
All right. Sounds good.
Phone will be the same Zoom session or a different one?
It will be the same Zoom session. I will keep the Zoom session on always.
Okay, all right, cool.
Yep.
Thanks.
So I'm going to step out and take a break, and then I'll come back and
See you at 1 o'clock.
at 1 o'clock, so nobody rushes their lunch, and we'll start.
Yep.
Okay, goodbye.
Bye.